Example 8. Two ships leave a port at the same time. The first ship sails on a bearing of 52 degrees at 17 knots, which is a measure of nautical miles per hour, and the second on a bearing of 322 degrees at 22 knots. How far apart are they after 2.5 hours? Round to the nearest nautical mile as needed. All right, so we have to draw this out. Okay, so I am going to put down a point, and this point is going to represent the port. Okay, so right here, this is going to be the port. Two ships are leaving from this port at the same time. So let's deal with the first ship. It is sailing on a bearing of 52 degrees at 17 knots. Okay, so let's go ahead and put the bearing in. So here's my east-west line, and then I'm going to put in my north-south line. All right, so it's going to look like this. Okay, remember we have a single number to express the bearing, so everything will be relative to due north. Okay, so we've got north, south, west, and east. Okay, so we need to align ourselves with due north, and then from due north, we need to rotate by 52 degrees. So you're just going to have to eyeball it, okay? So maybe something like this, okay? So here we go. I'm just going to drop it right there. This angle is going to be 52 degrees, okay? Now, remember, the length of the line segment represents the distance that this ship has sailed, okay? You are given kind of information about that. You're given knots, which is speed. When we're talking knots, that is the speed of a boat, okay? It's going 17 knots, meaning it's going 17 nautical miles per hour. Okay, so this 17 number is not a distance, it is a speed. However, we know that the ship is sailing on this bearing for 2.5 hours. So what we do know, and I'll go up here, this is going to be ship 1, okay, it travels 17 nautical miles per hour for 2.5 hours. Okay, so if you set it up this way, okay, the hours will cancel because you can think of it as, let me do it this way, you can think of it as 17 nautical miles per hour. Okay, the hours will cancel and you'll be left with distance, nautical miles. So in that 2.5 hour time frame, this particular ship has sailed 42.5 nautical miles. Okay, so that is a distance, and we can go ahead and label it in the picture. Okay, this is going to be a distance of 42.5 nautical miles. Okay, so after 2.5 hours, this is where ship 1 ends. Okay, so then, and I'll even write this in black, this is ship 1. Okay, I'll use a different color for ship 2. Remember, ship 2 is leaving from the same port. Okay, so let's go get the information about ship 2. Okay, it is going on a bearing of 322 degrees from the port, and it's traveling at 22 knots. Okay, so again, this second ship is leaving from the same port. Okay, it is going on a bearing of 322 miles. Or sorry, it's going on a bearing of 322 degrees. Okay, so we need to align ourselves. We're starting at the port, align due north. Okay, and we're going to rotate 322 degrees. Okay, so if we go, this is going to be 90 degrees, 180, when we're aligned with due south, 270 when we're aligned with due west, and then so we're going to end up somewhere in quadrant 4. Okay, it doesn't have to be exact. Okay, notice this ship is going faster. Okay, it's going 22 knots as opposed to 17. So if it's traveling for the same amount of time, it is going to go a little further. So this red line should be longer than the black line. Okay, so here we go. Okay, so this is for ship number 2. Okay, we know the bearing is 322 degrees. Okay, meaning if you start aligned with due north and you rotate around 322 degrees, you will end up on this red line segment. So I have marked off the angle 322 degrees. Okay, we can figure out the length of the red line segment. Okay, we can do that up here just like we did for ship number 1. Okay, so for ship number 2, we know it's traveling 22 nautical miles per hour. And it's traveling for the same amount of time. It's traveling for 2.5 hours. Okay, so if you set it up this way, the hours will cancel, and you're going to go to your calculator and do 22 times 2.5. Okay, it's going to go a total of 55 nautical miles in that time period. That's the distance it has traveled, 55 nautical miles. Okay, so I can go back to my picture, and that tells me the distance, this red distance, is 55. Okay, what are we trying to find? Okay, well, if you read the last sentence here, we're trying to say after the 2.5 hour mark, how far apart are the two ships? Okay, well, remember, ship 1 ends up at this black dot, ship 2 ends up at this red dot. Okay, so their distance from each other is represented by this blue line. Okay, so we need to calculate this blue line right here. Okay, all right, so to get that distance, we need to start working with the information that we have been given. Okay, we have a triangle. We know 2 of the lengths of the triangle. Okay, we don't really have any of the angles inside of the triangle, but we can start trying to figure it out. Okay, I'm going to work on this green angle right here. Okay, whatever that is. Okay, think about the red bearing. Okay, it almost went 1 full revolution. Okay, which would be 360 degrees, but it only went 322 degrees. Okay, so if we subtract those 2 angles, we're going to get that green angle is 38 degrees. Okay, it needed to go 38 more degrees to get a full revolution in. Okay, so we know that angle, and then we know this black angle that I have marked off is 52 degrees. That came from the bearing of ship number 1. And if you look at this particular angle, let's see if I can find a different color here. Let's do purple. If I look at this angle right here inside of my triangle, okay, it is comprised of the 38-degree green angle and the black 52-degree angle. If I add these 2 angles up, if I do 38 degrees plus 52 degrees, guess what that gives me? Okay, that gives me 90 degrees. 38 plus 52 is 90. Okay, that tells me that this is a right triangle. Okay, so I can go ahead and mark it off as a right triangle. Okay, so we are dealing with a right triangle. We know 2 of the sides of the triangle already. Okay, we are interested in the blue line, how long that blue line segment is. That is the side across from the hypotenuse. So that is the side across from the right angle. So this is the hypotenuse of the right triangle. All we need to do to get it, we learned from the previous example, we don't have to bother with any more of the angles. We just need to use the Pythagorean theorem here. Okay, you can only use the Pythagorean theorem with a right triangle. So that's why we had to go through the effort to make sure there was a right angle inside of the triangle. Okay, so c squared is equal to a squared plus b squared. We're looking for c squared here. We're going to pop in an a value. It doesn't matter which side it is. So we'll go ahead and say this is 55 squared plus the b value, the other side is going to be 42.5 squared. Okay, we'll go put this in the calculator. To get c squared, this is going to be 55 squared plus 42.5 squared. So here is c squared. So that's 4,831 point, I believe it was 25. Okay, so then if we want to solve this for c, we need to take the square root of both sides. Okay, the hypotenuse has to be positive. Okay, carry all the digits. Okay, so if we pop this into the calculator, take the square root of the answer. Okay, here we go. Okay, I'll write the full decimal expansion here. It's going to be 69.50719,387. Okay, and then we need to round it accordingly. The directions say to round to the nearest nautical mile. This is a distance. Okay, so we can go ahead. I keep doing this. This should be equals, because this was the full decimal expansion, and now we'll round it. So we'll put approximately, and we need to round to the nearest nautical mile. So after the decimal point, we have a 5. So we're going to bump the 69 up to 70. Okay, so the distance between the two ships is going to be 70 nautical miles. And that's it. We are done. Okay. This problem was made more difficult by having to factor in the speed, using the speed to calculate the distance. Okay. But remember, if you see a problem like this, okay, you can refer back to this example to remember how to do that.